Hello, I am Kumbhare Associate Professor, Department of Chemistry, DB of Dayanand College of Arts and Science, Solapur. Today we see the gravimetric estimation of methoxy group by Gisel's method. This is one of the important method for the estimation of this methoxy group. Now see the principle of this experiment. Firstly, we take a known weight of organic compound having methoxy group, and which is heated with excess of constant boiling hydrochloric acid, that is CHI. The methyl iodide produced in this experiment is passed in an alcoholic solution of silver nitrate. Silver iodide that is precipitated is weighed, and from the weight of organic compound used and weight of silver iodide precipitated, a percentage of methoxy group and number of methoxy groups per molecule can be determined. See the reaction for this experiment, that is, this is the methoxy group compound ROCH3, which is reacted with hydrochloric acid heated at 130 degrees centigrade. So there is a formation of one alcoholic molecule and methyl iodide, and this methyl iodide produced is absorbed in alcoholic silver nitrate. So firstly there is a formation of double salt AgI AgNO3 and CH3NO3, and this double salt AgNO3 is heated in presence of nitric acid. So there is a formation of a precipitate of silver iodide, and from which weight of the silver iodide we can calculate the percentage and methoxy group and percentage and number of methoxy groups. So this is the procedure. Accurately weighed methoxy compound, that is near about 0.2 to 0.3 into 10 raised to minus 3 kg. Then few pieces of unglazed porcelain pieces are placed in long necked distillation flask, which is shown in this figure, that is D. This is the flask, which is also known as Zelda's flask. To this flask, concentrated hydrochloric acid is carefully added, and the hydrochloric acid we taken is 15 cm3, whose specific gravity is 1.7 and boiling point is 126 degrees centigrade. The side arm of this distillation flask is attached to absorption flask A. Now this is the side arm of this distillation flask, which is attached to this absorption flask A, which contains 4% alcoholic silver nitrate solution. The apparatus is shown here. This is distillation flask. This is absorption flask A and B, both containing 4% alcoholic AgNO3. This is the oil bath in which we heat this distillation flask. Again there is a V tube. This V tube also contains alcoholic AgNO3 solution. Now see what is the procedure. A slow stream of pure and dry carbon dioxide gas is passed through the flask, and the reaction mixture is heated for an hour at about 130 degrees centigrade in an oil bath. So we also pass the carbon dioxide gas in this distillation flask. The methoxy group, that is OCH3, undergoes hydrolysis and releases volatile methyl iodide. The liberated methyl iodide is swept away by a current of pure and dry carbon dioxide. It precipitates an equivalent amount of double salt of silver iodide and silver nitrate. The completion of reaction is confirmed by detaching absorption flasks and connecting V-shaped tube containing 4% alcoholic silver nitrate. The distillation flask is again heated, and if no precipitate is formed in V-shaped tube, then it indicates the completion of the reaction. After the completion of the reaction, the contents of the absorption flasks and V-shaped tube are carefully transferred to a beaker containing dilute nitric acid and boil gently for an hour to decompose the double salt. Double salt on decomposition releases silver iodide and silver nitrate. Silver iodide remains insoluble. Then the solution is cooled. The precipitated silver iodide is filtered, washed, dried and weighed. Now see the calculations, how we can calculate percentage of methoxy group and number of methoxy groups. So from the reaction we carried out in this experiment, 1 mole of OCS3 is equivalent to 1 mole of methyl iodide. So that is 1 mole of OCS3 generates 1 mole of methyl iodide, and this 1 mole of methyl iodide gives us a double salt AgI plus AgNO3, and it gives AgI. So ultimately this 1 mole of AgI equivalent to 1 mole of OCS3. So from the molecular weights, that the molecular weight of AgI is 235 kg or 235 into 10 raised to minus 3 kg of AgI equivalent to 31 into 10 raised to minus 3 kg of OCS3 group. Now from this experiment, weight of methoxy compound used, that is initially we took the methoxy compound whose weight is W kg. And after completion of experiment, we got the precipitate of silver iodide whose weight is Y kg. So weight of methoxy compound used is W kg and weight of silver iodide precipitate is Y kg. Then from the above equation, again we write here above equation, that is 235 kg of AgI equivalent to 31 kg of OCS3 group. Therefore, Y kg of AgI equivalent to, so there is a cross multiplication, that is 31 multiplied by Y divided by 235 kg of methoxy group. That is W kg of methoxy compound equivalent to 31 multiplied by Y divided by 235 kg of methoxy group. So the for the purpose of percentage of methoxy group, this W kg of, that is the methoxy compound used, W kg methoxy compound equivalent to 31 multiplied by Y divided by 235 kg of methoxy group. Therefore 100 kg of methoxy group, that is percentage. Again there is a cross multiplication, 31 multiplied by Y multiplied by 100 divided by 235 into W kg of methoxy group. So this is the formula for this percentage of methoxy group to calculate from the above experiment. 31, that is the weight of methoxy group, multiplied by Y, which is the weight of precipitate of AgI, into 100 divided by 235, which is the molecular weight of AgI, into W, that is the weight of compound we taken. That is, it is simplified as 13.19 multiplied by Y divided by W. So when we put the weight of a silver iodide, that is Y, and weight of compound taken, then the result is percentage of OCS3 group. Also see the number of OCS3 group per molecule, calculation for number of OCS3 groups per molecule. Suppose molecular weight of methoxy compound is M, that is capital M. The compound which we took for the experiment, its molecular weight is M. We know already W, that is W kg methoxy compound equivalent to 31 multiplied by Y divided by 235 kg of methoxy group. Therefore M kg, that is molecular weight, M kg of methoxy compound equivalent to, again there is a cross multiplication, 31 multiplied by Y multiplied by M divided by 235 into W kg of methoxy group. Now 31 kg of OCS3 group equivalent to 1 methoxy group, because this 31 is the weight of 1 methoxy group. Therefore 31 multiplied by Y multiplied by M divided by 235 into W kg methoxy group equivalent to 31 multiplied by Y multiplied by M divided by 235 into W into 31. So we cancelled this 31 from numerator and denominator. The formula becomes Y multiplied by M divided by 235 into W methoxy groups. So number of methoxy groups formula is Y multiplied by M divided by 235 into W. That is, if we know weight of AgI formed, that is Y, molecular weight of methoxy compound, that is M, and weight of organic compound containing OCS3, which is used. So from these three values we can calculate the number of methoxy groups per molecule in this Gisel's method. So there is one example. This is in Gisel's method, 0.035 into 10 raised to minus 3 kg of a methoxy compound whose molecular weight is 108, produced 0.077 into 10 raised to minus 3 kg of silver iodide. Calculate the percentage and number of methoxy groups present in the molecule of the compound. So this data is given in this example, that is W, organic compound used is 0.035 into 10 raised to minus 3 kg. Y, that is AGI formed is 0.077 into 10 raised to minus 3 kg. And M is the molecular weight, that is 108. So this is the one formula, percentage of methox group, 31 multiplied by Y multiplied by 100 divided by 235 into W. We know the value of Y, we know the value of W. We are putting in this equation, and the result or the percentage of methox group in this organic compound containing methox group is 29.02. So this is the result, or this is the answer. In this way also we can calculate number of methox groups. We know the value of Y, 0.077 into 10 raised to minus 3. We know the value of M, that is 108. We know the value of W, that is 0.035 into 10 raised to minus 3. After solve, we get two number of methox groups in this compound. So in this way, by using Gisel's method for the estimation of methoxy group, now we know what is the procedure, and from this procedure we can calculate percentage of methoxy group in the given compound and number of methoxy groups per molecule in the given compound. Thank you. So this is the answer. No, sir.